Let's take a look from this question. This is taken from year 2019, the DSE past papers. Alright, so I try to highlight all the colors and put back the data in the respective positions. Alright, so in part A1, they want to ask for the angle BAD, right? Okay, so if you look at the focus triangle ABD, this triangle, you see that we have three pieces of information. Unfortunately, they are in the SSA configuration, so we have to use sine formula, SSA sine formula in triangle ABD to find angle A. All right, angle BAD, this one. All right. So when we use the SSA formula, be careful that there might be more than one solution, so we have to see. All right. So to invoke the sine formula, we have sine A divided by 12 equals to sine 72 divided by 13. All right. So from the calculator, we have angle A equals to 61.4. All right. It is 3899. All right, to be more accurate. But then don't forget there is an alternate answer. All right, not shown on the calculator. Is 180 minus. Right, 180 minus 61.3899. All right, there might be two answers. One is like this, the other is like this. There might be two answers in the SSA sine formula, ambiguous case, right? Fortunately, in this case, the second one is rejected because there is already a 72 here. All right. If you take this angle and add a further 72, that will obviously greater than 180 degrees. All right. So it violates the angle sum of triangle. So the second one is not accepted. So there leaves only one answer. Angle BAD will therefore be 61.4 degrees. All right. This is the answer to part A1. Now in part A2, we have to find CP, all right? Now, most importantly, try not to make the mistake that you mistake CP to be a right angle here, or you take angle P at point P as the midpoint between A and B, right? These are all wrong, right? There's nowhere mentioned in the question that point P is the midpoint, nor the foot of perpendicular. So do not make these assumptions. So how do you locate point P? Now, to look at point P, we have to look at this triangle. All right, this is where you find point P. All right, point P is the point where BP is perpendicular to AD, isn't it? So we can use the cosine ratio. In triangle. Now there is a plan. All right. In step 1, we use cosine ratio. We find DP in triangle BPD, right? Because there's a right angle here, so we can use cosine ratio. Plus, we know about this top angle. This top angle will be 180 degrees minus the 72, minus the 61.4. All right, because angle A is 61.4, so this angle ends up 64.41013, something like that. All right. Let me put in more accuracy. It's 61.3899. All right. All right. So this top angle is about 46 something. So we have DP equals to 12 times cosine angle D. All right, we have cosine angle BDP, so that we have the answer. DP will be 8.2435, something like this. All right, so that is step 1. This is point D. I'm sorry. All right. So now that with DP, you can put the length of DP into this part, and then you invoke SAS cosine formula. In the second step, we use SAS cosine formula in triangle CDP, all right, to find CP, all right. That's how we do it. Alright, now we have 13, we have the 60 degrees, and then we have the dp from here. So we can use SAS cosine formula to do this. Alright, you can do it on the calculator, right? So I did it on the calculator, and the answer of CP goes to 11.4. Alright, to use more accuracy, we have 11.39253, 11.4 cm. Alright, this is the answer. Now, but with 5 marks, I think there would be 1 mark for the application of the SAS cosine formula, right? When you write the SAS cosine formula, do not do this. If you have a squared and b squared minus 2bc cosine a is correct, but you will not have the 1 mark step mark, because the cosine formula must be applied in context. In other words, you must put down the name of the lines that you use the cosine formula. Alright, plus dp squared minus twice cd dp cosine 60, right? That will give you 1 mark for the step mark for the cosine formula. Alright, so sometimes it's careful that you have to express the equation, the formula, in terms of the context, not just use dictation to write down the formula. Alright, okay, so anyways, that is part A. That is the majority of the question. Part B is level 5 stuff. The craftsman claims that angle BPC is the angle between the two faces. So angle BPC will be this yellow angle. Alright. Now, in order for the angle, the yellow angle, to be the angle between the two faces, it needs to be a right angle on both lines. Alright. Angle between two faces means that you have a common line here, and then you have one face like this, you have another face like that. Alright. Then you have to draw you have common line, you have to draw perpendiculars along each surface. Alright, you have to draw perpendicular lines along each surface, and the angle between this perpendicular line is the angle between the planes. So in other words, the decision hinges on whether this angle is a right angle. In other words, it's here whether this is a right angle. If it is a right angle, then it is the correct angle between planes. If not, then not. So to decide whether angle DPC is a right angle, you can do it with the converse of Pythagoras theorem. We find out that CP squared plus DP squared is not CD squared. Alright, so therefore angle CPD is not 90 degrees. Now this will give you 1 mark, alright, for finding the critical angle. CPD is the focus angle in this decision. If it is not right angle, then the claim is wrong. Alright, then the claim is incorrect. Okay. Now there is one way to use the converse of Pythagoras theorem, because if it were right angle, then the 3 lines CP, DP, and CD should follow the Pythagoras theorem. Alternatively, because you have CP, right? CP is 11.4. How about DP? DP is we just did that. It's 8.24 something. Alright, it's 8.24 something. So you can use triple S cosine formula to do that. Alright, or use triple S cosine formula to find angle CPD. Alright. One way or another, you arrive at the conclusion that angle CPD is not 90 degrees. Now, this will also give you 1 mark. Alright? 1 mark for finding angle CPD. 1 mark for the decision that it is not 90 degrees to disprove the claim. Okay? So, that is the DSE question on year 2019 on 3-dimensional problems.